If the voltage is 12V and you know how big a capacitor is, how much charge can it hold? And what happens if you insert plastic between the plates? First of all, what is a capacitor? A capacitor stores electric charge. It's made of two conducting plates with a small gap between them. And this gap is usually filled with air or plastic, which is a dielectric. And here's the basic equation. Q equals CV, with Q being the amount of charge stored, C being capacitance, which is how much charge per volt, and V is voltage across the plates. This is on the free cheat sheet in the description, as well as the units, which are F for capacitance. F represents farad, with 1 farad being 1 coulomb per volt. And most circuits use microfarads or even picofarads. The circuits are really small. The parallel plate formula is this. So this was our basic charge formula. If the plates have an area of A and they are separated by a distance of D, then the formula is C equals this A over D, with C being capacitance. This is a constant number, permittivity, area over distance. This formula only depends on geometry. It does not depend on charge or voltage. And what it says is that wider plates means more room to store charge, and closer plates means a stronger interaction, which means a higher C. Here's an example problem. You have two plates with their areas being 25 centimeters squared and the distance between them being 0.8 millimeters. What is their capacitance? Their capacitance is permittivity A over distance, which is, so the permittivity of free space is 8.85 times 10 to the power of negative 12 multiplied by their area in meters. We got to do some conversion. 25 centimeters squared in meters is 0.025, with millimeters 0.008. The answer is 2.77 times 10 to the power of negative 11 farads, which is 27.7 picofarads. Both of these answers are valid. So when you put an insulator between the two capacitor plates, this insulator is your dielectric, and this dielectric, it boosts capacitance. Capacitance goes up. Here I've written out the new formula. C is capacitance, and this is the regular formula that we use. But when you throw in a dielectric, you have to add in this new thing, K, which is the dielectric constant. For vacuum, it's 1. For paper, it's roughly 3.7. For glass, it's 5. Water has a dielectric constant of 80, and titanate has 300. A bigger dielectric constant, K, means that it stores more charge at the same voltage. Why? Let's look at this from the molecular point of view. Why does a capacitor with the dielectric in between the plates have a larger capacity? First of all, let's draw our capacitor like this. Here's our two plates. This side has a positive charge and this side has a negative one. So positive, negative. And because it's two parallel plates, it's a uniform electric field, straight lines. What happens when you throw in an insulator, like a piece of plastic in between? So let's insert our dielectric like this. We'll color it red because it's special. It's got all its molecules in here, which are negative and positive. Just imagine that going all the way down, everywhere. The dielectric's molecule align slightly, and they reduce the internal electric field, which makes the plates feel like they are further apart than they actually are, without changing the actual distance. So bigger distance without having a physically bigger distance. What does that do? It boosts C, your capacitance. Here are some two important scenarios. The first one being when a capacitor stays connected to a battery, which means that there's a constant voltage coming in. Voltage will stay the same, it's constant. Capacitance increases, and since charge equals capacitance times voltage, the charge must increase even at a constant voltage. More charge is pulled from the battery. The second scenario is when the capacitor is isolated. So voltage is equal to charge over capacitance. When the capacitor is isolated, there's a constant charge. Charge does not change. But capacitance increases, which means voltage drops. There's the same amount of charge, but now the plates are less strongly separated, you could say, which means that there's a lower voltage.